Usually somebody in here is good for a couple. Number 9. I don't think I assigned. I think I assigned 1 through 8, and then 13 to 23 odds. So if you did number 9, that's why it was hard, because we didn't talk about it. And I don't need you to do it. So if you don't know how to do number 9, that's okay. I won't test on it. Number 3?
Yeah.
You didn't like the 9th root? Okay. So the 9, x to the 9th minus 9, not factorable, because it's neither a difference of 2 squares nor a difference of 2 cubes. So I'm just going to add 9 to both sides and then do the 9th root to both sides, because it's an odd root. It's no plus or minus. And it's done. That's all she wrote. Yeah. I mean, it's one of those, it's like, it's weird, but it's not hard. You know, it's like, is this what I do? All right, I'll do that. Yep, that's all you do. All right, anybody else? Yeah, Aves. 4? There's some plugged into the power strip up here if you want to use one. So we'll just take the denominator, set it equal to 0. I'm going to factor that to solve. You could use the quadratic formula if you cared to. The two numbers that multiplied to give you negative 14 and add to give you negative 5 are negative 7 and positive 2. Set each factor now equal to 0 and solve. And my asymptote should be, oh, this I'm supposed to be doing domains, excuse me. Should be negative 2 to negative, or negative 2 and negative 7 are my zeros. But then I'll just write my domain, which should be everything except for those two numbers. Luca, we should have written a domain here. Not that it's a difficult domain to write, but I didn't read the question. I just was like, oh yeah, da 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 da. Aves, what's up?
For number 3, it says it's like the domain is
Then it's a typo. It's a typo one place or the other.
Okay.
So either the typo was on the question, because that answer would make sense if it was x squared minus 9, or typo with the answer, where it doesn't match. You know what I'm saying? It's one or the other. Somewhere there's a typo. Cool? I'll try to make a note of that and remember to go back and edit that for next year. Okie dokie, artichokes. Let's get this show on the road then. 14-2.
Is it a long question?
Definitely not.
Okay, perfect.
I just have some examples to do, and that there's like no new concept.
Yay! Are we gonna have a test before we leave for free?
I don't want to do that.
Thank God. I didn't either. I just like rush here. Oh my gosh. Oh my gosh, wait.
Okay. all we're going to talk about here today is solving rational equations. So we'll do, I think I have 4 examples and I'm done. That's all I want to do. Cool? Okay. So I'm going to show you just one technique that can be used for all rational equations. I'd encourage you just to use one technique rather than showing you like a bunch of different things you could do and then having to choose. I'm just going to give you the one that on average is going to be the simplest to use in all settings. Everybody's cool? Okay, the name of this technique is called clearing fractions. My goal is to multiply both sides of my equation so that when I'm done, I will have no fractions remaining. Everybody's okay with that idea? So we have an equation. So I can always, if I do the same thing to both sides of the equation, nothing really changes other than what it looks like, right? My answers will stay the same as long as I do it to both sides. Everybody's cool? So the question becomes, what do I need to multiply both sides of my equation so that I can get rid of the fractions? And the answer to that question is going to be the least common multiple of the denominators. So your easiest situation is one like we have here in example 7, because how many denominators do we have? Well, there's really 3, but what are the other denominators? Just ones. And if you're making a least common multiple, does 1 do anything if you multiply it? No, so I don't even need to really worry about it. So my least common multiple of all the denominators is just going to be x, right? If I take my denominators, the least common multiple of them is x, because x, you get it. So I'm going to take that and multiply it to both sides of my equation. Everybody's okay? So I'll distribute the x through. So x times x is x squared. What is x times 3 over x? Good. You could think about it as 3x over x, which reduces down to 3. Okay. Everybody so far so good? What kind of an equation are we left with here? What type of problem is this? It is a trinomial, but more specifically than that, starts with a Q. Quadratic. There you go. To solve a quadratic equation, what do I do first? Not yet. I got to do something before I can do that. Make it what?
A plus C with A plus B.
Yeah, it needs to equal 0, right?
Yeah, that.
So Joey says subtract 4x from both sides. And now you could use the quadratic formula here. How else can we solve one of these, though? Factoring also. That's probably what I would elect to do here, because when the leading coefficient is 1, like it is in this problem, factoring is usually really easy and fast, and typically more enjoyable than the quadratic formula, which can be kind of tedious. So that's what I'm going to do here. So we're looking for 2 things that multiply to give us 3, and then add to give us -4. -3 and -1, right? I can then set each factor equal to 0 and solve to get 3 and 1. But we're not finished. We have to do one other thing. For a rational function, the domain is not always all real numbers, correct? We've seen that before. So, but what we ended up really solving was a quadratic equation. That's a polynomial whose domain is all real numbers. So it's possible that the solution to this quadratic equation was one of the values that are not in the domain of the rational function, which means they should not count. So what I need to do is I need to go back and check for an extraneous solution to see if I get an answer that appears to be an answer to the problem, but actually doesn't satisfy the original equation. This is really easy to do, though. All I'm going to do is I'm going to go back and see if I plug my answer into the denominators, does it make a zero denominator? So if I plug 3 in for x, do I get 0 in the denominator? Well, no, Mr. Kulik, I get 3. Great. And if I plug 1 in for x into the denominator, do I get 0? Well, no, Mr. Kulik, I get 1. Great. Then those answers are both fine, and we're done. Okay? Not a lot of extra work, but you do need to take that additional step and at least check. Do I need to write anything down? No. You just need to look. But you do need to look. All right, let's do another. All right. What should I multiply both sides of this equation by to clear the fractions? X plus 1 is the answer. Very good. Everybody feel okay? So I'm going to treat the x plus 1 as one thing and just distribute to each of the other terms. So I have x times x plus 1. What do I get when I multiply the x plus 1 to minus 6 over x plus 1? Negative 6. And the right-hand side is goose egg. So far, so good? Okay. So now I'll just distribute this piece out. What am I left with? Another quadratic equation, right? So I could either factor this or use the quadratic formula if either I can't figure out the factoring, or it just looks like, yeah, that's going to be hard for me to factor. I'm just, whatever. So what? How does this one factor? Negative 2 and positive 3. So when I set these equal to 0, I get 2 and then negative 3. If I go back to the original problem and plug those into the x in the denominator, do either of them make it 0? If I plug positive 2 or negative 3 into the denominator, does that make a 0? No. Nope. So what does that tell me? Both those answers are good. We just discard that one answer that makes a 0 and accept everything else. If that's our only answer, then we would say no solution. All right, let's do another. This is a goodie. Okay. Ooh, Boise.
Ooh.
Yeah, what's up, Fitzy?
Can I go to the bathroom?
I sure hope so. She's. You can push her in the hallway when you see her next or something.
Oh, I'll push her.
All right. So I want to start by multiplying both sides by something that's going to clear the fractions. What's that something going to be here? Yeah, we should factor the quadratic in the denominator so we can tell what our factors are. So how does x squared minus 4x plus 3, how does that factor? Good. So x minus 1, x minus 3. So what is going to be the least common multiple of the denominators?
X minus 1, x minus.
Correct. So that will if I take that x minus 1 times x minus 3 and multiply it by, or try to divide it by any of the denominators, I get a whole number. Is everybody okay with how I've gotten to here? I'm going to treat this all as one big thing when I distribute it through. What do I get when I distribute the x minus 1 times x minus 3 to 2x over x minus 1? I'd get something like this, right? But the x minus 1s are going to cancel. Here, Jake, you should take one of these. Actually, just take a picture of it and give it back to me. That's the schedule for when classes are this week.
All right, thank you.
Take a picture of it, though. I want to keep that. Okay. I'm just trying to help a guy out, right? It's clear that he didn't know what time things started. All the days are different, so take a picture.
I know. I didn't even know this. I didn't even know until this morning.
Yeah, it's okay. Shh. Okay, let's try to finish this one up. So when I multiply x minus 1 times x minus 3 to 1 over x minus 3, what do I get? I get x minus 1. And then what do I get when I multiply x minus 1 times x minus 3 to 2 over x minus 1 times x minus 3? Just 2. Because what I'm multiplying is the same as the denominator, so just like everything cancels out. Shh. And we can just distribute things through. Let's combine some like terms. I'll move everything onto one side. What do you notice here that's different than the previous ones? What's happening here that's different than the previous problems? The leading coefficient is not 1. It's 2 in this case. That's what I circled in blue. Good job. So, is it possible this thing is still factorable?
No.
Sure, it is. Does it require me doing that more complicated version of factoring? Yes. What am I going to do instead? Just use the quadratic formula. Because even if this is factorable, it's going to be just about as time consuming as the quadratic formula will be. And the quadratic formula actually guarantees that I'll get an answer. So I'm going to take that route here because it's the leading coefficient is 1. And it's a little bit less obvious by looking at it whether it's going to factor or not. What's up? Oh, okay. So I have 25 plus 24, that's 49. And the square root of 49 is 7. Just do that. 5 plus 7 is 12. Divided by 4 is 3. 5 minus 7 is negative 2. Divided by 4 is negative 1/2. So those are my answers. Am I finished? No, I got to check. All right. X equals 3. If I plug that in for x, does it create a zero denominator anywhere? Yes! Zero denominators, right? Does it matter that it didn't happen in all the denominators? No, it just has to happen in a denominator. This solution I discard. The vocab we call this guy an extraneous solution. You don't have to use that vocab, but I'm just going to say, I think it probably happens in directions here and there to make sure you check for extraneous solutions. That's what we mean, is this situation here. If I plug the negative 1/2 in, though, any problems there? No, right? You know what else is distracting? The people that are talking in the back of the class the whole time. I don't know who that is. Somebody must have done it, though. All right. One more example, and I am donezo's. Can we hang in there for one more?
Yeah, a little box and more don't look at me, don't talk to me.
All right. New rule, nobody talks to Mary.
I think Mary talks to everyone.
Just when she starts talking, you just turn your head. Okay. All right. One more example. What do I need to do to start? Factor that denominator. It's the same denominator that we just saw a minute ago, so that's easy. What do I do next? Multiply both sides by? Good, that is the least common multiple of the denominators. Okay, now what? Great. Again, we're going to treat that as like one big thing, right? So what do I get when I do 2.5 over x minus 3 times x minus 3 times x minus 1? Yes, those guys are going to cancel, leaving me with just the 2.5x minus 1. Great. And we do the next one. What do we get? Great, because those guys cancel. So 0.5x minus 3. And then what does that all equal? Just x squared. Everybody super duper? Okay. So we'll distribute those things through. So I have 2.5x minus 2.5 plus 0.5x minus 1.5 equals x squared. If I combine my like terms over here, I get 3x minus 4. Now what? Get it all onto one side, right? I'm going to move it onto this side so the leading coefficient on my x is still positive 1, because that makes the factoring easy. How do I factor this? Multiplies to give me 4, adds to give me negative 3. It doesn't factor. I tricked you. What do we do if it doesn't factor? Yeah. I'll put that note next to it. So I get 9 minus 16. That's negative 7. Ruh-roh, Raggy. What happened here? So what do I say here? Well, let's add the word real in there.
No real solution.
Yeah, and we can be done. Because that piece would give us an I. That's all I want to do today. You guys should now be able to work on numbers 25 through 32. Yeah.
Can I follow her?